Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Quartile and today we'll be doing Unit 7cc, Lesson 6, Choosing Appropriate Statistics. So it's important, right, to always revisit the central idea of statistics, which is that we are answering a statistical question, right? A question where the answer's got variability in it. So it's very difficult to give like a solid mathematical, x equals 7 kind of answer, right? The answers are squishy, they're laced with probability and uncertainty and things like that. But we develop statistical tools to do the best job that we can to answer these questions. The real question becomes, what are the right tools? Now, when we answer a statistical question, we often use a measure of center, like the mean or the median, and a measure of variation, like the interquartile range or the mean absolute deviation, aka the IQR and the MAD, right? Which measures that we choose to use really depend on how the data in our data set is distributed. So let's take a look at that in exercise number 1. Juliet runs a science experiment to answer the question, how long can a person hold their eyes open before they need to blink? She collects data from a random sample of 15 people, which is shown below. The data is in units of seconds. Letter A asks us to construct a dot plot of the data on the number line below. All right, great. Well, what I'd like you to do is pause the video for a moment and construct this dot plot. That should be pretty easy. All right, well, obviously, in order to conduct a dot plot, all we need to do is just plot our data. So I'm going to put 1 point at the 8, 1 point at the 10, a couple at the 11, 1 at the 12. We've got 4 13s, 1, 2, 3, 4. We've got 3 14s, 1, 2, 3. We've got 1 15, 1 16, and 1 18. All right, a nice little dot plot of the data, a little ugly. And again, I want to be very clear about something in statistics. Almost all the problems that you work with in statistics, both at the middle school and even at the high school level, they don't have enough data that a normal experiment would have. Most experiments in the real world, you're going to have at least 30 subjects, at least 30, and it could be up to hundreds or thousands of subjects. So we would have a much more involved dot plot than just this one. Let's keep going and take a look at letter B. Draw a box plot below the number line for the data set. Then calculate the interquartile range and state its value and the value of the median below. All right, well, in order to draw that dot plot, and we'll move that number line back down so that we can get it on there, we need to have that 5-number summary, right? Our min, our max, our first quartile, our third quartile, and our median. So why don't you figure that out for our 15-value data set, okay? Draw your box plot, and then we'll take a look. All right, keep in mind, right, if we've got 15 values, an odd number of values, there will be one number right in the middle. And it's easy to think about what that is by always just taking the number of values, that's 15. This is what I do. I subtract 1 off, I get 14, divide by 2, and I get 7. Why 7? That means there'll be 7 on the lower half, 7 on the upper half, and then the 8th value will be the one right in the middle. So let me find that one. 1, 2, 3, 4, 5, 6, 7, 8, right? That is my median. Okay, now that leaves us with 7 values down here and 7 values up here. In order to find my first quartile, remember, I'm going to take a look at the lower half of my data set without taking into account the median. I'm going to look at these 7 values. Again, I can think about which one would have to be the median of this data set, this particular data set, by doing 7 minus 1, that's 6, divided by 2, that's 3. That means I'll have 3 here, and the median will actually be the 4th one, right? That's going to be my first quartile. And I can do the same up here, right? It'll also be the 4th one here, so Q3. All right, and that should be enough to figure out to draw my box plot, right? Because I can draw a line at my minimum at 8. I can draw a line at my maximum, right? 18. I can draw a line at my median, 13. I can draw a line at Q1, that's 11, and a line at Q3, 14. And I can draw my box plot. I'm just going to scroll up here for a second, right? You know, box plots and dot plots are just two visual representations of a data set. Obviously, the dot plot allows you to see really nicely where all the little data points are, whereas the box plot shows you very concisely the minimum, the maximum, the first quartile, the median, and the third quartile. Now, this problem also asked us to state the value of the median, so I'm going to just do that right here, even though I have it up above. The median is 13. All right. Now, right, the median and the interquartile range, was I supposed to do that on here? Oh, I was. I was supposed to calculate the interquartile range. I never did that. The interquartile range is going to be my Q3, 14, minus my Q1, 11, which is going to be 3. I knew I was forgetting something. So the median and the interquartile range always kind of get paired up, right? In other words, if you're going to talk about a central value and a measure of variation, you know, to summarize a data set, then one choice would be the median and the IQR. Another choice, though, would be our mean and our mean absolute deviation. Those two also get paired up because they're linked with one another, all right? So in letter C, it asks us to calculate the mean and the mean absolute deviation for the data set. Round the MAD to the nearest tenth. All right, okay, so this is a fairly large data set. Pause now, figure out what your mean is, and then use your mean to find your mean absolute deviation. The mean should come out rather nicely, but the MAD is going to be something that you'll need to round. So take some time, this will take you a few minutes to do, and then let's revisit it. All right, let me see if I can get all of this into my calculator correctly. First thing I need to do is I need to clear that out, and I'm going to sum all my data up. 8 plus 10 plus 2 11s plus 1 12 plus 1, 2, 3, 4 13s. One of them, two of them, 3 of them, 4 of them. All right, I got my 4 13s. Now I need 3 14s. A 14, a 14, a 14. Now I've got 1 15, 1 16, and 1 18. You gotta be very careful when you add all of these things up on your calculator. We find that the sum of the data, if I saw correctly, was 195. And so the mean will be 195 divided by 15. Where's my calculator? Let's just do divided by 15. And that gives me a mean of 13. And look at that. My mean and my median were identical in this case. Now, we've got the mean. Now we have to calculate the MAD. Now remember, to calculate the MAD, what we need is we need the distances that each one of these 15 values is away from that mean. So let me write those down. Here we go. The MAD always takes some time to calculate. So the 8, that is going to be 5 units away from the mean. The 10 is going to be 3. The 11 is going to be 2. Another 11 is 2. The 12 is going to be 1 unit away from the mean. Then we have those 13s that are all 0 units away from the mean, because they are the mean. The 14 is 1 unit away from the mean, and there are 3 of those. The 15 is 2 units away. The 16 is 3 units away. And the 18 is 5. So now my MAD will come from adding up all of those distances and dividing by how many there are. I think I can do the addition in my head, and then we'll do the division on the calculator. 5 and 3 is 8. Plus 2 is 10, plus 2 is 12, plus 1 is 13, plus 1 is 14, 15, 16, plus 2 is 18, plus 3 is 21, plus 5 is 26. So we have 26 then divided by 15. That is definitely not the nicest number on earth, which is why we will have to round. It's 1.73 repeated. So to the nearest tenth, 1.7. By the way, we pointed this out in the last lesson. Oftentimes the MAD is slightly more than half of the interquartile range. The interquartile range was 3, half of 3 is 1.5, and the MAD is 1.7, slightly larger than half of the interquartile range. Now, it really boils down to the thrust of the lesson. Let's take a look at letter D. Why would either measure of center and either measure of variability work well to describe this data set? In other words, at the end of the day, right, we're trying to answer this statistical question, right? How long can a person hold their eyes open before they need to blink, right? And the natural tendency when you answer a question is to first give a measure of center, like either the mean or the median. But they're the same in this case, right? They're both 13 seconds. So whether we said, well, the average amount of time was 13 seconds or the median amount of time was 13 seconds, right? They're both right there in the middle. Right? That is the middle of this data set, 13 seconds, right there, right? No question about it, right? As well, the fact that MAD is slightly more, or right around half of the IQR, tells us that both of those are good representations of how much variation there is in this data set. Now, why is that happening? Why are the mean and the median basically the same? I mean, they're actually exactly the same in this case. And why are the MAD and the IQR both pretty representative of the variation? Well, the reason it's happening is that this is a data set that is pretty symmetric. It's not perfectly symmetric, but the data set is fairly symmetric and it has no outliers, right? It's mostly symmetric with no outliers. Mostly symmetric with no outliers. So the thing that you worry about, right, in all of statistics is that you may use a statistic or you may provide a statistic which would misrepresent the sort of average value or the amount of variation, right? And you can imagine, having a room, right, where most people in the room are right around 5 feet tall and somebody walks in and they're 7 feet tall. Right? And you say, what is the average height in the room, right? Because of that outlier, that person who's 7 feet tall is so much taller than everyone else, it's going to drag the mean height up. The median is still going to be around that 5 feet tall, but the mean may not now represent the average or center value of the data set very well. So, of course, if we look at a data set that's sort of well behaved, like exercise number 1, in exercise number 2, we want to take a look at one that's not so well behaved. All right, when a distribution is symmetric about its central values, like what we just saw, then either the mean and the MAD or the median and the IQR summarize the data set well. It is a different matter entirely if the distribution is what is known as skewed. I love that word, skewed. It's a word you can say again and again. All right, so let's take a look at exercise number 2. Matteo is trying to answer the question, how many pull-ups can a typical 7th grade student do? He takes a random sample of 15, apparently that's my favorite size of a data set, a random sample of 15 7th grade students to see how many pull-ups they can do in a row. The data is shown on the dot plot at the right. Letter A asks us to determine the median and the interquartile range of the data set. All right. Great. So we're going to start by just figuring out that first, central value and that first, measure of variation. I'd like you to pause the video now. It's a little bit more challenging because the data isn't sort of just listed out all in a row, right? You're going to have to think about how to do that with a dot plot. And of course, one possibility is you literally list all 15 values out, starting with 1, and then 3 2s, and then 4 3s, and then 2 4s, and 1 5, etc. If you need to do it that way, that's great. I'll show you kind of a way to do it with a dot plot in a moment, but take a little bit of time now and figure out what both the median and the interquartile range are. All right, so let's do it. So first, remember our kind of thought experiment, right? We've got 15 values. All right, if we lined them all up in a row, you'd have the bottom 7, the upper 7, and the 8th one would be the median. So how do I find the 8th one? I just start to count, right? I've got 1, 2, 3, 4, 5, 6, 7, 8. So the eighth one is actually just 3, right? 3 pull-ups. So the median is the eighth value, my magic red pen, which is equal to 3, right? So the median is 3. Now, the first and the third quartile are a little more challenging, right? But if you think about it, right, you'd have the lower 7 data points, and the first quartile would be the 4th one, right? Because you'd have the lower 3, the upper 3, and then the 4th one right in the middle. So the 4th one would be 1, 2, 3, 4. So Q1 would be equal to 2, right? Now, likewise, we can kind of think about the 4th one from the top being Q3. So we could go 1, 2, 3, 4. So Q3 is equal to 6. And therefore, the interquartile range is going to be 6 minus 2, which is equal to 4, right? So we have a median of 3 pull-ups, sounds about what I could do, if that, and a variation of the middle 50% of 4 pull-ups, from a Q1 of 2 to a Q3 of 6. Now, this distribution is very different from the other one, though. And it's known to be skewed to the right. So letter B asks us, why do you think this distribution is referred to as skewed to the right? Why do you think that's how we call it? Pause the video now and write something down. Well, the reason for it is because there is a long tail to this data set. A tail is sort of like data that stretches out, but there's not much of one, and that only points to the right, right? If we had also a long tail that went out and pointed to the left, then this would be a nicely symmetric distribution again. But we've got all of the data basically clumped down here on the left, and then the data skews to the right. We've got it out pointed to the right. A long tail of data only to the right. All right, easy enough. Now, letter C asks us to find the mean of the data set to the nearest tenth, draw it as a dashed line on the number line, and then they ask, why would this not be a good measure of the center of the data set? This is cool. All right, now this is going to take you a little bit. Pop out those calculators and find the mean of this data set to the nearest tenth, and then kind of draw it on your number line, wherever it is, in a nice dashed line so we can really kind of think about whether or not the mean is a good measurement of the center of this data set. Pause the video now and go ahead and do that. All right, just like before, this is a bit of a challenge to calculate the mean because all we have is the dot plot, but, right, we can certainly take our calculators out, clear out the previous problem. We can just start putting them in here, right? We've got 1, 1, we've got 3 2s, right? We've got 4 3s, we've got 2 4s, we've got 1 5, we've got 1 6, we've got 1 8, we've got 1 10, we've got one person who can do a lot of pull-ups at 14, right? So we find that the mean is going to be the sum, which is 70, divided by how many people there were, 15. I wish I could just keep that out here, but it doesn't like to do that for me. That makes sense. And we get 4.6 repeated, which rounded to the nearest tenth is 4.7. All right, I'm going to go back into full view mode. I'm going to draw that roughly on my number line, which is right about here. Now let's talk about this part of the question, which is very important. Why would this not be a good measure of the center of the data set? I want you to think about this a little bit. Pause the video now and think about why it would be a little bit misleading, right? If you're trying to talk about the answer to this question, right? How many pull-ups can a typical 7th grader do? To say, well, the mean number of pull-ups was 4.7. I mean, it's not false. It's definitely like 4.7 is the mean. But why would that be a little bit deceptive in terms of the one number that represents all of this data set? Pause the video now. Well, think about this. What we really kind of want with both the mean and the median is we want it kind of right in the center. We want to be like, yeah, you know, about half the people less than this, about half the people more than that. But if you look at this mean, there are 1, 2, 3, 4, 5 values above it, which just using subtraction means that there's 10 values below it, right? That's not in the center of this data set anymore, right? It's really not very close to the center. So this isn't a good measure of center because there are way more data values below the mean than above the mean. Way more data values below the mean than above the mean, right? And again, that's happening because you've got these few data values out here. I would include the 10 and the 14, right? That are so far above where the other ones are that they are literally, just based on the arithmetic of how you calculate the mean, they're pulling, right? They're pulling the mean away from the median. Remember, the median was down here at 3, which seems very, very representative of the middle of the data set, right? That 3 makes all the sense in the world as being like something that you'd report. Oh, well, there was a median number of pull-ups of 3 pull-ups per student, right? You know, versus the mean, that's, you know, that almost makes it seem like the typical 7th grader can do 5 pull-ups, but not very many of those 7th graders could do 5 or more pull-ups. Now let's also talk about the measures of variation. Letter D. Matteo uses a spreadsheet to find that the mean absolute deviation of the data set is 2.7. Why would this not be a good measure of the typical amount of data, the typical amount a data value is away from the center? Remember, that's what our MAD really should represent, which is the typical amount that a data point is away from the center. Why is 2.7, which, you know, if you want to think about it as the number 3, that's fine. Why is that not a great representation of the variation of this data set? Think about this for a minute. Well, again, we want to think about the MAD as being the typical amount that a data point is away from the center of the data set. Now, it's calculated as the typical amount that a data point is away from the mean, but we really want to think about it as the amount that it is away from the center of the data set. Now, if you think about it, right, the center of the data set is right in here, right? And most values are either 1 unit away, right, or 2 units away. In fact, right, if we looked at all the values of the data that were within 2 units of that center, it would be all of this stuff. Only these things would be more than 2 units away from the center, and yet the MAD is 2.7. And again, that makes sense because you got these values here that are so far away from the center that they're making the average distance from the center or from the mean much larger. So the way I'd answer this question is, right, the typical, well, actually, maybe I'll say this. Most data is within 2 units of the center. So the MAD is too large, just like the mean. Side note, right, the MAD in this case is 2.7. What was our IQR? right? Our IQR was 4. And remember, in a typical data set, one that's symmetric, no skew or anything like that, the MAD tends to be just a little bit bigger than half the IQR. Now the IQR is 4, half of that would be 2. Here, our MAD is almost 3. Now you might say, well, 2.7 is only slightly more than 2. Well, not really, actually. It's like comparing 27 to 20, right? That's like 27 is considerably larger than 20. 2.7 is considerably larger than 2 in this context. So the point now is that in this kind of scenario, we would not want to use the mean or the MAD to represent the central value and the variation. We would want to use the median and then the interquartile range. So, right, letter E, make a summary statement about this data set using the median and interquartile range. In other words, right, what we want to do is we want to answer the question. And it's real simple, it's real dry, right? The question was, how many pull-ups can 7th graders do, right, in a row? And what we would want to say is we wouldn't want to mention the mean or the MAD. We would want to say the median number of pull-ups was 3 with an interquartile range, an IQR of 4. All right, so let's really summarize what this lesson is all about. And it's pretty simple. In general, if a distribution is skewed, right, if it's got a tail that points out in one direction or the other, very often the tails point out to the right, right? But they don't have to. It could be a tail pointing out to the right or the left, right? You got this skewed distribution. Then it is best to use the median and the interquartile range to describe the data set. In those skewed situations, what happens is that the mean and the MAD can be misleading in terms of these types of distributions, right? A wonderful example, by the way, is the distributions of household incomes in the United States, okay? In the United States, the median household income for 4 people tends to be around $60,000 a year. But the mean tends to be much higher, like $75,000. And that's because there are some very, very wealthy people that are at the way end of that skewed distribution that pull the mean up, right? But if you want to think about what the typical household income is in the United States, you don't want to think about the mean because most households don't meet that mean, right? But many of them meet that median. In fact, half of them are above it and half of them are below it. For some students, they might say, well, look, if I'm going to report on a statistical question, then the safest thing to do is to use the median and the IQR. But oftentimes, we love using the average, right? We love using the mean, but you have to be careful with it when you have a skewed distribution. All right. So today, we looked at actually a pretty complicated statistical topic, which is which statistics do you use to answer a statistical question? Maybe you throw the kitchen sink out there. Maybe you use everything you possibly can. But really, it depends on the shape of the distribution. If the distribution is nice and symmetric, it looks basically the same on both sides, no tails stretching off in only one direction, then whether you choose the mean and the MAD or the median and the IQR really doesn't make a difference. But as soon as you get outliers in one direction and not the other, when you get skew pointing in one direction and not the other, then it really is important to use the median and the IQR to answer your statistical question. All right, well, thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.